still working with systems of linear equations, so everything's going to be to the first power. But the difference is yesterday we're talking about things with 2 variables, and today we're talking about things that have 3 variables. So these kind of systems are going to look more like our checkpoint 1. Okay, so as you can see, I've got 3 equations with 3 variables. If there are 3 variables, I have to have 3 equations to be able to completely solve this. Now, we still have some of that other stuff that's going on, because when you have something in 3 variables, we are talking about space. So I really can't draw a good picture of this, because we've got the x-axis, and we've got the y-axis, and we've got this imaginary z-axis that goes through this way. So these lines represent lines that go through space as opposed to just being flat on the surface here. So it could start here and go through and behind the board and underneath it. Okay? So it's very hard to draw these, but I want you to think about the fact that we do have these lines that go in lots of different directions. So for it to have just one solution probably is not the thing that most often happens, right? Because that means that all 3 lines have to intersect at just one point. Whereas before, just had 2 lines. Well, if you don't even think about the fact that some could be leaning forward and leaning back, you could have something like this, right? Where not all 3 of them touch at the same time. So we are going to have some no solution problems where they're not necessarily parallel. There's just no one spot where all 3 of these lines all hit at the same place. So I just want you to be aware of the other options on our solution. But when we do have a solution, our solution is what we call an ordered triple, because there are 3 pieces to it. And they do them in alphabetical order usually, and so they would write the solution for x, the solution for y, and then the solution for z. So on this objective 1, what we're talking about is just trying to see if something is actually a solution. And so they want us in checkpoint 1 here to determine if -1, -4, and +5 is a solution to this system. So what would you do? What would your process be? Plug it in. Plug it in where and in what? The -1 goes in for all the x's. -4 goes in for all the y's, and 5 goes in for the z's. And so you can just sit there and plug those in and work those out. I got that all written down correctly. And so now, and remember, I am checking to see if this is actually equal. That's what I'm doing. The first one's good. So we get 22 is equal to 22, so that one works. And I got -2 and +12 gives me +10 minus 5, so this one works. And -3 minus 7 minus 25, yep, -32 is equal to -32. So the answer is that yes, this is a solution. Okay, that's objective 1. That's all there is to it. That's exactly right. Be very careful with those signs. Okay, the second objective in here says we're actually going to solve these systems. Okay, so they're not going to give me a solution. We're actually going to find a solution. And unlike yesterday or last time we were in here and you had some choices about how you were going to solve it, there is only one way that's a reasonable way to solve these systems of equations. Okay? And it is done with the addition method, or kind of a variation of the addition method. So checkpoint 2, here's my system, x plus 4y minus z equals 20. 3x plus 2y plus z is equal to 8. And 2x minus 3y plus 2z is equal to negative 16. Okay? So, no. We're going to do one of those in a second. Where one of the terms is missing. Okay? Actually, having terms that are missing actually causes us less work. We don't have to do quite as much work. I'll show you in a second. All right. So, I'm going to call this equation 1, equation 2, and equation 3, just so that I can refer back to them because we do start doing some combinations with this stuff. What you have to do is you have to put these 3 equations together 2 at a time. And on the first 2 steps, when you do that, you've got to eliminate the same variable. So I'm going to take equation 1 and equation 2, and I'm going to work with them to eliminate, and I think I'm going to eliminate z, because I see right here that z is a nice, easy thing to eliminate. I don't have to multiply through by anything. Everybody see that? I got a positive 1z and a negative 1z. Nope, it's being smart. It's working smarter, not harder, right? Is it the only way to do it? Nope, I could have gotten rid of the x's and that'd been just fine. Okay, so we're going to use the same method that we used before, but we just got to do it more times. Okay, so I'm going to use 1 and 2 together, and I'm going to add that together. And so I get 4x plus 6y. Here's my 0 pair that I planned on, and that's equal to 28. I'm going to call this equation number 4, because I get a new equation. I don't just get a variable. I get a whole new equation, but it's got one less variable in it, right? So I'm going in the right direction. Now, I've used 1 and 2 together. I must use equation 3 in the next set, and then it doesn't matter if I use 1 and 2. No, I got to go back, because 3 has how many variables in it? It's got 3, so I must use an equation that's got 3 variables in it to be able to get rid of it. Okay? So we can use 2. I probably would have used 1, just simply because it's already got the right negative sign. Because if I got rid of z in the first set, I must get rid of z in the second set for this to do any good at all. So I'm actually going to do equation number 1, but I'm going to multiply it through by 2. So I'm actually going to do 2 times 1, the number 2 times equation 1. Everybody understand? I'm going to take 2, and I'm going to multiply it through by equation 1. So I'm going to get 2x plus 8y minus 2z is equal to 40. Okay, so I just took equation 1, and I multiplied through by the number that I needed so that it was going to get rid of z when I added it with equation 3. Could have done the same thing for equation 2. Doesn't matter which one you would have picked. I'm multiplying by 2. Yeah, that's what that little 2 out there in the front means, is I'm multiplying it by 2 so that I can add them together and get rid of something. Okay? Then I'm going to add, so I get 4x plus 5y. There's my 0 pair like it was supposed to be, and that's equal to 24. And that's equation 5. So you take the original equations and pull them apart, get rid of the same variables in the 2 sets. One equation does have to be used over one time. Okay, so all 3 equations get used once, and then one of the 3 gets used the second time. Everybody understand that? Okay, now what I'm going to do is I'm going to take equations 4 and 5 and put them together. So I got 4x plus 6y is equal to 28, and 4x plus 5y is equal to 24. Now, if I just add them just like they are, am I going to get anywhere? What did I need to do? One of them by -1. You want to multiply the bottom one by -1? Okay, so you want to do -1 times 5, so that would make it -4x, -5y, and -24. Is that good if I go ahead and just fix it right there? I don't have to write it down again, do I? See, I put over here what I did to it. Okay, now I'm going to add it together. Here's my zero pair. So I get y is equal to +4. That's exactly what you do. Now we know y, so I can go back to either equation 4 or equation 5 and plug the y back in. Yeah? You see what I did? Okay. So, I know y. I've got to go back into one of these two equations, which just got two variables, and plug y back in. So I'm just going to pick number 4. So I've got 4x plus 6 times 4 is equal to 28. Okay? I just plugged it into one of the two. It doesn't matter which one. So I've got 4x plus 24 is equal to 28. So 4x is equal to 4, so x is equal to 1. So now I know x and I know y. What do you think I have to do to get z? 1, 2, or 3. That's exactly right. So if I plug it back into 1, so x is 1 plus 4 times 4, which is what y was, minus z is equal to 20. I'm going to take it back into 1 and use 1 just because it was handy. So I've got 1 plus 16 minus z equals 20. So 17 minus z is equal to 20. So negative z is equal to +3, and z is equal to -3. So my ordered triple is the point 1, 4, -3. Nothing hard about this process. It's just fairly long. Okay? So it's pretty much going to take a whole piece of paper, or at least a half a sheet of paper, to do each one of these problems. Okay, when I'm looking at this and I'm grading this, I have to see which equations you put together and what your new equations were. Then I have to see where you put the two new equations and what you got here. Now after that, that's just plugging in. I don't have to see that necessarily, but I do have to see those first 3 steps. You can't put that in the calculator, that's the deal. The rest of it you can, because you're just plugging it back in and you're kind of working it out. Now, any questions about that? All right, so DJ asked us about what happens if we've got a set that's like got a missing piece to it. So let's look at checkpoint 3. Okay? So, like I say, what happens here is that we actually get to cut out a step. I don't need an equation 5 if I do this carefully. I want you to look at what I could do. If I take the second and the third one together and get rid of x for my equation 4, then I could put 4 with 1 and work with those. Okay, so missing a variable just means I take the other two that aren't missing the variable, get rid of something, make them miss that variable. That's exactly right. So if I call this equation 1 and this one 2 and this one 3, then I'm going to take -2 times equation 2 and add that to equation 3. Everybody see why I picked that? That's what it's going to take to get rid of the x. So this gives me negative 2x minus 4y minus 2z is equal to negative 34. Everybody see what I did? Took equation 2, multiplied through by negative 2. Now I'm leaving 3 alone. 2x minus 3y plus 2z equals negative 1. Oh, look, we got rid of a z too, didn't we? Okay, so we got rid of the x. Y gives me negative 7y. The z's went away too, and that's equal to negative 35. So y is equal to positive 5. Since I didn't get a y and a z, at this point I can just start working backwards and plugging stuff in. Because I can come up here, since I know y is 5, then I can do 2 times 5 minus z equals 7, right? Once I can solve for one variable, I start going back and just plugging things in. So we've got 10 minus z is equal to 7, so negative z is equal to negative 3, so z is equal to positive 3. Now I've got y and z, so I'm just going to go back into equation number 2 that's got all 3 variables. X plus 2 times 5 plus 3 is equal to 17. So x plus 13 is equal to 17, so x has to be 4. So my ordered triple is 4, 5, 3. So like I say, it's really do kind of like it and having something missing out of it because it reduces the amount of work that you have to do. As an ordered triple, you either have to write it this way or you can write it as an ordered triple. It doesn't matter. Okay? Not yet. You need to see the application problem. Yeah, there's a checkpoint 4. Yep. Are we ready? Okay, the last objective is the application of this process. There is an application. And it is checkpoint 4. It says find the quadratic function. That y is equal to ax squared plus bx plus c. Right, quadratic function. So I need to know what a, b, and c are. Quadratic function whose graph passes through these 3 points. 1, 4, 2, 1, and 3, 4. Now I want to know what quadratic function passes through those 3 points. So the only thing that you really have to remember to be able to do this problem is that in a point, first number is the x, the second number is the y. So you can plug that back in, right? So this says 4 is equal to a times 1 squared plus b times 1 plus c. Everybody see that I put 4 in for y and 1 in for x. Then I get a second equation that comes from the next point. So I get 1 is equal to a times 2 squared plus b times 2 plus c. And then I get a third equation that says 4 is equal to a times 3 squared plus b times 3 plus c. Huh? This is how you do it with algebra. You remember how if I had 2 points, I could use the algebra and I could find the slope between the 2 points and I could put it in the point-slope equation and I could find the equation that passed through those 2 points? This is how you find the curve that passes through these 3 points if it's quadratic. Okay? Any questions? All right, so we do need to simplify this a little bit so we can it's easier to look at. So this is a plus b plus c is equal to 4. Is it all right if I put it over on the other side since we've been working with it on the other side? And then I've got 4a plus 2b plus c is equal to 1. And 9a plus 3b plus c is equal to 4. there's my system of equations. Here's my equation 1, 2, and 3. Now, once you got that set up, now I use the exact same process that I used a minute ago. I'm going to use them together in sets of 2s, and I'm going to get rid of one of the variables. Which one do y'all want to get rid of first? Doesn't matter. Get rid of A, B, or C, but C is going to be the least amount of work to get rid of. The C's, they all have the same coefficient. All I got to do is make them. Okay? All right, so I'm going to take 1 and 2. And which one do you want to multiply through by negative 1? 2. All right. So I've got A plus B plus C is equal to 4. Negative 4A minus 2B minus C is equal to negative 1. Just took the second equation, multiplied through by negative 1. So when I add that together, I get negative 3A minus B, the C's canceled out, is equal to 3. And that's my equation 4. Now, I've used 1 and 2. I must use 3. 9A plus 3B plus C is equal to 4. And I've got to get rid of C, right, for this to work. But it doesn't matter if I use 1 or 2. So which one do y'all want to use? 1, because it's the easy one. And so we're going to do negative 1 times 1. So get negative A minus B minus C equals negative 4. Right? Everybody see it? Okay. So when we add this together, we get 8A plus 2B equals 0. But remember, that's legitimate. We can have it equal 0. It's just if the letters all disappear, that's when we start saying we have either infinitely many solutions or no solutions. Okay? So now we're going to put 4 and 5 together. But I want you to kind of evaluate it before you start writing it down. What would be the best and easiest thing to get rid of now? Okay, so if I take number 4 and multiply it by 2, that's going to give me something that's going to get rid of the b's, right? So I've got negative 6a minus 2b is equal to 6. And then the fifth one we're going to leave alone. So 8a plus 2b is equal to 0. I'm going to add those together. So I get 2a, 0 pair, equals 6. So a is equal to 3. Now once I have a, I can go back into 4 or 5, either one, to find b. So I'm going to use 4. So I've got negative 3 times 3 minus b is equal to 3. Right? So see, I just took equation number 4 and plugged a in for it. So I get negative 9 minus b is equal to 3. Add 9 to both sides. Give me negative b is equal to 12. So b is equal to a negative 12. Right? And then I've got to go back into one of the first 3 equations. I'm going to pick equation number 1, because that one was a plus b plus c equals 4, right? So we know a is 3, b is negative 12, plus c is equal to 4. So I got negative 9 plus c is equal to 4, so c is equal to 13. Yeah, it doesn't matter, as long as it's got all 3 variables so that you can use it. Okay. Now, remember what I was trying to do was I was trying to find a, b, and c so I could come up with my equation that works here, my quadratic function. So y is equal to a, 3x squared minus 12x plus 13. That's the quadratic equation. And if you'll put it in your calculator and draw the graph, you'll be able to see that it actually does pass through these points, 1, 4, 2, 1, and 3, 4. But doesn't we messed up somewhere? Okay. There are also some other word problems in there, but they're very easy to decipher. No real worries about how to do it. You just read the equation and write the stuff down. Your homework for this section is on page 513. And you're going to do 4 through 36 multiples of 4. Now, I know that's not very many of them to do because they take so long to work out. I didn't give you a whole lot. You may want to do more than 9 problems just because you need the practice, because this will be on the test. So, it's up to you.